Hey guys, today we're on Unit 7, Lesson 7. We're going to be starting some log word problems, and today we're going to be dealing with mainly financial problems. So we're going to begin by just a few quick notes. We're going to talk about this term called interest. Now, interest has many kind of different meanings, but for our purposes here today and for what we're going to be doing in this course, we're going to say that interest is going to be money paid for the use of money. And I'm sure you can all understand that concept of, you put money into the bank, the bank uses your money, and different bank accounts have different levels of interest that you can make if you have your money in a different type of account. So there's going to be two main formulas that we're going to be working with in this course, and you saw them last year as well. And the first is going to be compound interest. And our compound interest formula looks like this. So it's A equals P times 1 plus R over N to the NT power. And basically here, A is going to be your final amount. P is what we call our principal, or the initial amount. R in this equation is going to be the rate, the interest rate. N is equal to the number of times it's compounded per year. So for instance, if it's compounded semi-annually, that's going to be twice. If it's compounded monthly, that's going to be 12, N would be 12. If it's compounded daily, N would be 365. So you sort of have to know those numbers. And obviously T is time. Now, the other type of interest problem we're going to be dealing with is when it's compounded continuously. Now, this is kind of hard to understand, but as N goes to infinity, okay, so it just means it's continuously compounding. Our formula changes, and this is what you guys all know from last year as the APERT formula. A is all, still the final amount. P is your initial amount, or the principal, what you walk in the bank with. R is still your rate, and T is still time. E is our number, right? E is our number E. Okay. When we calculate, or when we use our calculator to evaluate these, I'd like you to start using the second ln key, because it's going to open up E raised to, and you don't have to worry about, putting parentheses in or anything like that. And then one more important thing that we have to squeeze onto this page is when your interest is given to you in a percent for either case, we have to move our decimal 2 places left. Right? So we always have to change our percent into a decimal to plug into our formula. All right, in the first set of problems here, all we're going to do real simply is we're going to find the end result, find the amount of money. We're not really solving equations right now. We're just inputting into our formula. Find the amount of money you will have after 1 year if you invest $1,000 at a rate of 10%. Okay. So we're going to do this annually, quarterly, monthly, daily, and continuously. So I'm going to start by just saying my rate, my 10% is really going to be, if I move my decimal place, 0.1. So anytime I plug in my R into my formula, I'm going to be putting it in as 0.1. The amount of money I have, I'm starting with 1,000. I'm using, this is going to be compound, and N is going to be once a year. And I have my N times T. So it's 1 times 1. And you're just going to plug this in your calculator. I know I don't really have to do all this button pushing because this one's easy, but I just want to show you how I would do it and all the parentheses. And I'm going to raise to the 1 times 1%. Oh, yeah. And I would wind up with $1,100. Okay, so in these examples, we're dealing with the amount of money we're going to have, not the interest. Okay. The interest was $100, but the amount of money we're going to have, the end result. Quarterly, you're going to set up the same formula with n equals 4. Monthly, same formula with n equals 12. Daily, same formula with 365. Now continuously, right? When we see the word continuously, we're going to jump to that APERT. Now I'm going to give you a few minutes. I'll write down the work and I'll show the work, but this part of the lesson you should be able to do pretty much on your own. I want you to get a feel for plugging the numbers in. If you have to pause the video and stop at any moment, that's fine. And generally speaking, I know we usually go to 3 places, but with money, we're going to round to 2 places. Okay. And I mean, I don't know how important it is, but notice how, similar those two are. I think they're off further down in the decimals, but, basically a daily and continuously, a lot of times they're going to be very, very close in number. Once again, this is just like inputting into a function. I just wanted to get you the practice of putting the right things in the right place. Hopefully you took the time and you struggled through it and didn't just copy me. Now let's look at some different types of problems. Very, very easy and straightforward. How long does it take for a principal of 2,000 to increase to 4,000 at an annual rate of 10% compounded continuously? Okay, so when I read my problem, I'm looking for these things. When I see the words compounded continuously, I'm using this formula. Now I have to decide what to put where. So I want it to increase to 4,000, starting with 2,000. At 10%, it's still going to be 0.1, and I'm solving for t. So there's where you want to notice your variable is the power. Isolate your variable. So e to the 0.1t equals 2. ln both sides. Now, some of you at this point already know that you're going to bring that down, and that's okay. I usually always write it. Oops, I forgot to write it on this side. ln of e is simply 1. So I have 0.1t equals ln of 2. So t is going to be ln of 2 divided by 0.1. And you could just do that real easy on your calculator. 6.931 years. And for the most part, I'm just going to say, go out 3 places, even if it seems like a weird, messy answer, unless they say round to the nearest year. We're just going to use 3 places as our designated rounding spot. Now, in this next example, how long does it take for an investment to double in value if it's invested at 6% per year, compounded monthly, and then compounded continuously? So we want it to double in value 6% per year. So I essentially have 2 separate problems here. I'm going to be compounding monthly, so I'm going to be plugging into this formula. And then when I do the continuously, we're going to be using that formula. So there's 2 separate problems here. All right, so now I have to figure out, how do I express double in value? Okay, they didn't give me a place to start with. I could use different numbers. However, it's a good idea to start to learn, just to understand that if you start with p, any amount p, and you double in value, your final amount is going to be 2p. I'm at 6%. I'm compounding monthly. And what happens is your p's are going to cancel out. Now, I only say this because some types of problems, are going to be weird. You're going to be taking a percentage of something. So it's nice to understand that whatever you start with, okay, you can double it, you can triple it, you can quadruple it, whatever you want to do. And then the p's are just going to cancel out in the end. I'm just going to clean this guy up a tiny little bit here. 1 plus 0.06 divided by 12. Oops. Okay, so this is really 1.005 to the 12t. ln both sides. ln of 2 equals, now here, if you see this is, you can bring your power down and find right away if you'd like. This time I don't have ln of e, so I'm going to have to do a couple more steps. Remember, trying to get the t by itself, that's your variable. So I'm going to divide by 12 times ln of 1.005. ln of 2 divided by 12 times ln of 1.005. And I get 11.581 years. And now let's look at the continuously. So now we're going to be using the same situation. I still want it to double, right? So I have my P and I want to turn it to 2P. My rate was 0.06 and I'm solving for T. My P's cancel. I ln both sides. And this time it's nice because my ln of E is just 1, so I can cancel that. And T is going to be ln of 2 divided by 0.06. ln of 2 divided by 0.06. T is going to be 11.552 years. Okay, so it's really not, I mean, it's pretty simple stuff. I think what we do this year in this course is a lot easier than some of the stuff you did last year in Algebra 2 trig. So our final question today, what annual rate of interest compounded annually should you seek if you want to double your investment in 5 years? Okay. So we're compounding annually, so we're using compound interest. Now I'm going to substitute in, fill in the information that you know. I want to double, so I want to turn P into 2P. I don't know what my rate is. It's going to be compounded annually, so N is 1. And I want to double my investment in 1 times 5 years. Now I'm going to shrink this up a little bit. I'm just going to condense into to look and see what I'm looking for. Now in this example, look where your variable is. Your variable is inside a set of parentheses. So you have to undo, right? In order to get it out, you're going to have to raise each side to the 1/5 power. And don't worry that your numbers look weird because you have your calculator. So this is going to undo each other, right? And you're left with 1 plus R equals 2 to the 1/5. Solving for R is going to equal 2 to the 1/5 power minus 1. 2 raised to the 1/5 power minus 1. And R is going to be 0.148. But remember, that's a decimal. In order to convert it back into a percent, and usually our rates are given to us in percents, we're going to move this now 2 times in the opposite direction, and R should be 14.8%, which I don't know where you'd find it. Oh, actually, I'm bad. It should be 14.9%. A little off in my rounding there. Okay. So again, this is one of those situations where you definitely want to practice your homework just for little things like this, like the differences in where the variable is and what to do to solve it. Okay, we'll see you again tomorrow.